All right, guys, we're going to move on to exponential functions, but as word problems, okay? So in the real world, exponential functions are used to represent situations such as savings accounts. I'll highlight these because these are going to be the important parts. Savings accounts, interest, chemical breakdowns, and the value of a vehicle. Today we'll be reading a couple scenarios and writing an exponential function to represent each scenario. Now, up here at the top, this is just a quick review. So we've already learned this, okay? So the situation says the amount of money in a savings account after 2 years can be represented by this function. If you remember, this is in the form a b to the x. Now we know that a will always be our initial amount. B will always be our factor. Now b also tells us whether this is growth or decay. So the initial amount is going to be my a value, which happens to be the 1,200. So that's my a value. Is this equation representing a growth or decay function, and why? So to represent growth or decay, that means I look at the number inside, my b value. Well, 1.35 happens to be bigger than 1, so I know that this is growth because 1.35 is bigger than 1. What is the percent rate? So to find the percent rate, this is kind of the hardest one to do. So what you got to do is you got to take your b value and subtract 1 from it. So in this case, we have 1.35. And when we subtract 1, if you do it in your calculator, you should get 0.35. But again, it's asking for a percent, so you multiply that by 100. So it's growing at a rate of 35%. That's just a quick review and overview of what we did in those last couple lessons. So if you need a refresher, I would go back and rewatch those videos. Now, we're going to be using something similar to this. So this is what we're used to seeing. Today, we're going to introduce a new type of formula, but it's actually really the same thing, just written differently. So here's our y, here's our equals, here's our a. Everything inside of here is really our b raised to the x, but in this case we're going to raise it to the t because we'll be working with word problems. Now, depending on the situation, if your word problem happens to deal with growth, you're going to use this little formula. So really, a is the total amount after 2 years, so that's just what your answer is. P will always be your initial amount, just like before. This part here, you're always going to use a plus if it's growth. That's going to be really important. Now, in the word problem, they're going to tell you that it might be growing or decaying at a certain amount, so you'd put the percent over 100. So you'll take this percent out and put whatever it is, and then you'll raise it to, if it asks us to solve it, then you'll put a number in for the t. Now, it's just a couple of things down here because we're going to have to tell whether it is growth or decay. So here's some words. So interest means growth. Appreciation, something that appreciates, is actually growing. Same thing if they use the word increases. Now, the only difference between growth and decay is going to be this part right here. If it's going to be decay, instead of a plus sign, you're going to have a minus sign. But everything else, if you notice, everything else is going to remain the same. Now you got to look out for these words. Anytime they use the word breakdown, that means decay. Depreciation, like if you buy a brand new car, after 5 years, the value is not going to go up. It's actually going to go down. So it depreciates, or if they use the word decrease. Okay. Now I screenshotted a picture of this to use that as a cheat sheet if you need to. So let's jump into the word problems. All right, example number 1. The current population of a town is 10,000 people. The population is increasing at a rate of 20% each year. So those are some important things. So we're going to break this down. So question A, what is the initial amount? Well, if the current population has 10,000 people, my initial amount is obviously 10,000. Does this situation mean growth or decay? Well, if I look at the word increasing, I'm going to say that this is growth because of the word increasing. So which formula would we use? So if I go back over, so which formula would I use? If it's growing, that means I'm going to use this formula right here. So I would put in here A equals P 1 plus, because it's growth, the percent over 100 raised to the T. So that's the formula we're going to use. So this right here is the ultimate question. This is kind of the goal for today. Write a function P of T to represent the total amount of people in the town after T years. Well, right here they're telling me what I'm going to name my function. So P of T equals, now according to my formula, P goes first. So P is your initial amount, which happened to be 10,000, parentheses, 1 plus. So I'm just kind of copying what I have here. Now the next part is percent over 100. So my percent, they told us up here, was 20 over 100. Don't put the percent sign. I'm going to close it off, and I'm going to raise it to the T. There's my formula. There's my function. And you're done. All right, example number 2. Dylan invested $600 in a savings account. Probably going to be pretty important. At a rate of 1.6% annual interest rate. Now the word interest, I know, happens to be right here. So I know that's going to be an important word. He made no deposits or withdrawals on the account, and the interest was compounded annually. All right, a lot of information. Part A, what is the initial amount? How much did he start out with? Well, according to the word problem, he started out with $600. Does the situation mean growth or decay? Well, according to our little cheat sheet, interest means growth because of the word interest. Now, which formula would we use? Well, that would have to be the one with the plus sign. Write a function d of t to represent the total amount of money Dylan would have after t years. So d of t just means basically what I'm going to call my a. So d of t equals, now, okay, what's my initial amount? So it'd be 600, 1 plus, so the next part is percent over 100. So my percent is 1.6, it's okay if it's a decimal, over 100, raised to the t. There's my function, or AKA there's my equation. Okay, now you're done. Here's a little extra example. How much money will Dylan have after 6 years? Well, if you think about it, that's the whole point is why we wrote that equation. So I want to know after 6 years, which means I'm basically going to use substitution. So I'm pretty much going to copy all of my numbers. But instead of a t, remember t represents time. Well, 6 years is my time. So I'm going to replace it as an exponent, a little 6. So that's the only kind of the analysis question. Now what has to happen is I now need to type this whole thing. I have to type this whole thing into my calculator. So I have 600, parentheses, 1 plus, I have 1.6 over, there we go, over 100. I'm gonna raise this to the 6. So all I did is I substituted in the 6 where the exponent was. Now after 6 years, I'm gonna have 659.9537. So let's see if I can copy this. So I have, and we're talking about money, 659 point, I already forgot what it is, 9537. 0.9537. Now if you think about it, this is money, right? So if you go to the register, it's going to cut you off here. So look at that 3. Would that make that round up to a 6 or stay a 5? So my final answer would be $659.95 is how much money he would have. All right, so we got one more example. So why don't you pause the video and see if you can answer this one all by yourself, and then check your answers with what I got. All right, so example number 3. Your new car costs $32,000, but it depreciates, it's gonna be an important word, in value by about 18% each year. Part A, what is the initial amount? Well, my car started out at $32,000. Does this situation mean growth or decay? Well, according to my little cheat sheet from my notes, depreciates means to decay because of the word depreciates. So which formula would we use? So that means for this formula, instead of the plus, we're going to use the subtraction sign because, again, this value is going down. Same thing, percent over 100, raised to the t. So part D, this is what you really need to know how to do. Write a function c of x to represent the value of your car after x years. So c of x equals, so my initial value is 32,000, parentheses, 1 minus, now my percent was 18 over 100 raised to the x, because they're saying x years. So there's my equation. Part E, what will your car be worth after 4 years? Well, there's some time, so it looks like I'm just going to rewrite everything but replace it with a 4. So 32,000, 1 minus 18 over 100 raised to the 4. So, and again, how much will your car be worth? We're talking about money here. So I gotta go back to my calculator. So I have 32,000, 1 minus alpha y equals, get you your fraction. So 18 over 100. I'm gonna raise this. So I use my little caret button here, okay, which I pressed it twice. I'm gonna raise it to 4 as an exponent. I press enter. Let's change that to a decimal. So it looks like my car is gonna be worth 14,467, 0.896. All right. So I have 14,467.89632. 89632. Okay. So again, we're talking about money here. So that means I go out 2 decimal places. So if I take a look, that 6 is going to make this number round up. So 89, so my final answer will be $14,467.90 would be my final answer. have any questions, please schedule me. Either we have office hours, so make sure you look at the office hours stuff that I posted. I'll be available to do video conferencing if you guys are having trouble with this. If not, go ahead and give the classwork a try.